Thank God. All right, guys, welcome to Mastering LINQ for everyday use. Wow, full room. I'm really humbled having you all here at this lecture. I know there's some excellent talks in the other rooms right now, and seeing you all here choosing to listen to me is a privilege, and I will do my best to answer your expectations. It will be quite an interactive session today. There will be a lot of demos, and I will also be asking some questions to you. Or you might want to participate and ask me a question. And for the brave hearts among you, there's some goodies here, some VR glasses. I think VR is kind of a popular theme at this DevReach, so whoever is brave enough to participate and answer, get back to me after the lecture, and you will receive your prize. All right. Before we begin, a couple of words about myself. My name is Vladimir Milev. That's me. It's my fourth time at DevReach. My career so far has been interesting. I spent close to 9-10 years at Progress Telerik, where I've built desktop and web UI controls and also helped them with the business intelligence platform. After departing from there, I founded New Venture Software, where I served as chief software architect. We did a lot of consulting, training, and custom software development for Fortune 500 companies. This is new from a month and a half. I have the honor and privilege of being part of CoBuilder, a great company doing its part to digitalize the construction industry. I'm tasked with forming a team, building exciting new products, which are doing some bleeding edge technology stack like .NET Core, Angular 7, Azure Cosmos DB, and Azure Service Fabric. So if that sounds exciting to you too, just to let you know, we are hiring. And if that's not enough to convince you, we also have one of the best teams in the IT, best football teams in the IT football championship, so that might be convince you. All right. Right, guys? Okay, so on to the agenda for today. I will start with a short introduction about LINQ. Then we will compare together the differences between procedural and a procedural style of querying data and the LINQ way. We'll talk about a bit about method groups and lambdas. We will cover deferred execution and iterators. We will stop by the IQueryable interface and all the LINQ expressions. We will also be doing some LINQ expression construction during runtime with the .NET APIs. And last, we will also take a look at some ways to extend LINQ with some custom operators. All right, so when I said I will participate in DevReach and I will be talking about LINQ, I did a great deal of thinking of how do I want to present this. And this is the idea I came up with. In my mind, in order to master, because the lecture is called Mastering, it's really hard to master something in 50 minutes. But in order to master any given technology, you need to understand it. And best practices and techniques and examples, they're great, but they do not work without the context and understanding of the technology. So, in my opinion, the best way to learn is to do. And today we will do exactly this. We will experiment and learn together, coding side by side. I'll try to put myself in your shoes and work together, do some experiments. And unlike what many other speakers do, I will not be telling you beforehand what I will be doing. First, we will try some things, and then we will recap after that. There will be 5 demos, I think. And after each demo, we will do some recap and see what we learned and what we discovered. Also, you will see me using LINQ a lot during this presentation. It is an excellent tool. It's really awesome. By the way, Joseph Al-Bahari is not paying me for this. Maybe he should, but anyway, we'll be using that because it's really convenient and we'll be utilizing a lot of the features. Not to be confused with something else, which many of you might know. Okay, so let's go ahead. What is LINQ? I mean, we all know it's an abbreviation for Language Integrated Query. But what really is LINQ? Well, it's, in my opinion, in my mind, when I think about LINQ, I usually think of it as a universal approach to working with data. Before it appeared, people had to use different ways to work with data. For example, if you had in-memory data in your application, I somehow managed to press mute. Don't ask me how. Magic, yeah. We will be talking a lot about magic today, by the way, but it will be compiler magic. So, yeah, where was I? So LINQ is a universal approach to working with data. So back in the day when we wanted to work with data in memory, with C#, for example, we had data structures and algorithms. If we wanted to work with data in SQL Server, for example, we had to use SQL language in order to work with that. If we wanted to work with data in XML, we had to use XPath, and so on and so on. All different kinds of technologies for each specific type of data. Well, the grand idea of LINQ is to be an umbrella technology, a facade for the architects among you, to be able to work and access this data regardless of where it is located in the same way. There are several core technologies which enable LINQ to work. I've split them in these groups. So the first one is I call LINQ to objects, and it is implemented through the system LINQ enumerable class, and it targets the IEnumerable of T interface, allowing you any typed collection to be queried in a type-safe manner. Basically, if you've ever worked with .NET, you know that every single collection or sequence or something that represents a set of many items implements IEnumerable. So this is LINQ to object. It works on objects in memory using .NET compiled methods and delegates. The second type of LINQ technology I think is very important. I call it LINQ to anything. It is implemented through the system LINQ queryable and targets the IQueryable of T interface. And it is allowing the construction of expression trees that can be translated by any underlying implementations, for example, such as entity framework. It works on objects that could be anywhere because it is using expressions. There's some other technology also that helps us work with LINQ, helps the whole thing happen. And these are some helpful types like func of T and action of T. These are delegates. They have many overloads. Who of you has used these here? Great, great. Yeah, I mean, if you're a .NET dev, you should be using those. So, and I mentioned magic, and there's actually quite a lot of compiler magic going on in order to allow you to use LINQ. So, to name a few, anonymous types, quite important. We wouldn't have LINQ working the way it works without them. Implicit local typing, the var keyword, iterators, method groups, lambda expressions, and extension methods, of course. So I said we'll be doing a lot of demos, so let's jump straight into the first one. It's a comparison of the old and the new ways of accessing data. It's sort of an introduction. So how do you see the text, by the way? Is it big enough? Can you read the code, or do you want me to zoom it in? Okay. So here's what we have. I'll walk you because I couldn't possibly have do all the demos if I have to write all the code. I have something prepared. So we have just a main method which takes a directory info instance and gets all the files in this work directory. We can see they're just some files, some JPEG files, a bunch of pictures, pretty pictures. And after that, we have implemented, using the old-fashioned way, a show top 10 large file summary method, which takes all of those, and I will show you what it produces. It gives you the 10 biggest files, and also provides a pretty thumbnail preview for them. So let's look how it achieves that. So first of all, we need to, when we are working, we need to return a list of this summary info object, which is basically, we're not interested in all the details about the file info. We only need the name, we need the size, and we want the preview image. And we also, pretty standard, we can instantiate this class from a file info instance. So what we do here, we declare our list where we will store the results. Then we sort it. Unfortunately, if we don't provide this, we will get an exception. .NET doesn't know how to sort the file info object. So in order to use array.sort, which was the classical way to sort stuff in .NET before LINQ arrived, it requires us to implement a file info comparer, which is just a simple implementation of the iComparer class. By convention, in .NET, the compare method must return negative number if the thing on the left is greater, 0 if it's if both numbers are equal, and a positive number if the thing on the right is bigger. So simply, I'm using the length property because we want to sort them by size. And it is of type LINQ, which implements compare to. And we simply wrap this thing. And it allows us to sort. However, by default, sorting is from smallest to largest. So we also had to implement this reverse. And then the second operation we had to perform on this set of data is pick the top 10 items. We can do this easily with a for loop and a limit of 10. And after that, we perform projection using this helper method, and we return the results to display. So, as you see, it works. It's fine. That's totally reasonable. However, let's do it now with LINQ. So we start off with the files. I showed them already. It's just a, let me comment this out. It's just a list of all the things from the directory info of the get files return value. So first thing, we need to sort this collection, and we want to sort it in a descending order. So how do we do this? Order descending, file, and we sort by file length. And you can see already we are sorting. We don't need a comparer. We don't need any of those things. After that, we need to take the top 10 elements. We simply take 10. And finally, all we have to do is project, and this is using the select operator. And we just do from file info. And we're done. It took us a single line of code to do what actually before LINQ required us to write a separate class and such a long method. And actually we can make it even shorter. Do you know how? Any takers? Yeah. And use? Yeah. Yeah, it's called a method group conversion. So simply like this will also work. I had a slide on method groups. If we have time, I will show you something cool if we can. But this is basically this is called a method group. It's called a group because it could refer to several methods because of method overloading, early binding, and compile time polymorphism. So anyway, it expands it. However, we can also write this whole thing. If you're thinking LINQ, a lot of people do it in another way. All right. And because the query syntax of LINQ doesn't support the take operator, we can do it like this. And here we go. We have the same result. Something else, the query syntax doesn't support. It doesn't work with method groups, obviously. So that's about it. But I guess the main idea of this demo is to show you how much time you can actually save writing code. In this day and age, I think you absolutely shouldn't be using anything else. If you can use LINQ, you shouldn't be using anything else. It's let's say you wanted to change the query. You wanted to get some other information too. For example, how many files there are from more than 10,000 bytes inside. It's very easy too. And we just count. And there's 76, more than 10,000. They're all more than 10 bytes. Okay, so we have 45. So second question, do you know how we can make this shorter too? By the way, any ideas? Okay, yeah. Who come claim your prize after the lecture? So yes, we can move this thing. Second question, third question, do you know what this thing is called inside the count? It's a special type of delegate which returns Boolean. Yes, predicate. Great. So already 3 of the prizes are gone. So yeah, it's good to when you work with LINQ. It's always nice to go and check if there's some overloads which are taking some extra stuff because it comes really handy. Sometimes we can make it even shorter. Imagine how much code we will have to write otherwise. All right. So. What we learned, there's this LINQ syntax which is incredibly powerful. There are 2 syntaxes though, 2 implementations if you wish. There is the query syntax and the method syntax. They work the same way. They're just a matter of style, matter of personal preference. There's some difference though. Method syntax has more operators, and in my opinion is generally more flexible, such as it allows the use of method groups I mean C# already has a syntax. It's called methods and arguments. You don't need a second one. So this presentation will focus on the method syntax, and if you were expecting me to write all the LINQ queries in the query syntax, I'm sorry, but you will have to deal with it. All right. I spent way much more time than I care to admit on that last slide. So second demo, deferred execution and iterators, or being lazy is good for once. So let's explore the deferred execution. Right. So we have a CSV file. Let me show it to you. You can do absolutely anything with LINQ view files, everything. So it's a standard CSV with year, score, and title. So these are all the movies of Robert De Niro and their scores from the Rotten Tomatoes website. And we want to parse this using a iterator. And iterators are a classic way to approach operations, scenarios where read operations are expensive and we want to be as lazy as possible. So let's do it. We will declare, first we want to produce a list of this class, strongly typed. So I'll start. We'll just give it the path. All right. And but before that, we need to parse the file first. So we'll do this read operation. Yes, these should be static. Good call. And this one should also be public. So we'll just instantiate a reader. And there's something left to read. We'll read a line. And we also want to skip the header. All right. And we want to call it here. And convert it, project it. First, we want to split it by comma because we have a CSV file. And after that, with each string array that we get from the previous operation, we will map it. Excuse me? Okay, we'll see. And we need to return this. It's just a character, it doesn't allow you. But it works. I tested it earlier. I mean, it's a live demo, of course. If something's gonna fail, it's not gonna fail during your rehearsal. It will fail on the live presentation. Yeah. Yeah. Okay, so we have ear. Let's parse it. Let's do the rating. Okay. Thank you. All right. And let's call this. Yeah, it's difficult to speak and type. Thanks. All right. Let's just see what we have. So we've parsed it successfully. Let's add some logging here to see what's going on. So now we have some logging here. All right, let's see what happens if we just create the query. We don't have anything logged. Let's take the first 10 elements and see if something happens. nothing is happening. Why? Because we have, oops, we have an iterator, and the way the iterator works is um, it only triggers when you call the get enumerator. So from this query, all right. So let's move on. So if we get an enumerator, and do move next, let's put a breakpoint here. So now we hit move next, and you see it's the first time we enter this iterator. And we read the line, yield the result, go through all the lambda, which is lazy, and we can actually see, where's my enumerator? Yeah. Here. It's, where's current? Okay. We go through this and we print. And what's cool, if we do it again, you see we go here through the iterator, and it's basically a state machine. It's one of that compiler magic things I was talking about. So the iterator goes into the loop and then exits, yields control back to the caller, but it remembers the state. And so next time when we call iterator move next, it re-enters the same loop that existed before, but it remembers the state. It remembers where it was. So it will provide you with the next element. And it will print out something else, another movie. And actually, let me just see if I can show you this in IOSpy. It's not showing up for some reason. Okay, let's do this real quick. Let's write the simplest iterator possible. And call it. So you see, there's this compiler generated class which implements IEnumerable, IEnumerator, IDisposable even, which is this whole state machine I was talking about. So it's quite a bit of stuff happening. So let's, because we're moving ahead with time, let's continue here for a bit with our query. There are some interesting things we can figure out. So we see take triggers nothing. However, what will happen if we enumerate the query? It will read, I don't need this. It will read only 10 lines from the file. However, if we add some ordering, What do you think is going to happen? Yeah. So why is this? What's going on? Huh? All right. And there's something else. If we comment this line and we run it again, there's nothing happening. Okay. Do you want to do my presentation? What happens if we do first? Even if we don't enumerate it, if we call the first operator, the whole thing gets read to memory. So what's going on is these different operators, they behave in a different manner. And if you go, there's a really nice table here in MSDN documentation, which documents, classifies these operators by their manner of execution. And you see some of them trigger immediate execution, others do deferred streaming execution, and others deferred non-streaming. So what we learned: LINQ operators can be classified into three different categories. So the first ones are immediate operators. They cause the data source is read and the operation is performed at the point in the code where the query is declared. And there's the deferred operators, where operation is not performed at the point in the code where the query is performed. Happens only when the query is enumerated. However, there can be two types. Like take operator, which is streaming. It can work on data either item by item, such as select, or only with the subset that is required, that is the take operator. And non-streaming operators, which need to read all the items before they can produce a result, such as order by. So it's very important to keep this in mind for performance reasons, as we maybe have time to see later, because, well, so all of this magic of deferred execution and lazy loading is achieved, as we've seen, through iterator language construct. And as I said, there are some pitfalls to consider. So if you use toList, you should be aware that this will materialize the whole operation into memory. However, if your initial read is very expensive, that might be a good thing to do, actually, and to cache the results. So it's it depends on your judgment as a developer. And we've also learned a bit about iterators. Basically, they're instructions to build, compose, and iterate a list. It's compiler magic. It creates a nested class acting as a state machine, lets you avoid fully loading large lists into memory, and allows working with lists in piecemeal fashion. Actually, it allows you also to perform data operations in this lazy manner, which we call deferred execution. And you can even create infinite lists in this manner, but unfortunately, I had a demo plan for this, but we had a lot of stoppage, so let's move on. The next demo is about IQueryable and how LINQ works anywhere using lambda and expressions. So I will just go to the final because we will not have time to type it all. So LINQ supports a connection using LINQ to SQL to a local DB database. So this is just an object which implements the IQueryable interface. So if we go back to one of the other examples, we see that all of these, if we invoke the IntelliSense, they accept Okay, maybe this is not a good example, but how about this one? Okay, so I will need some more time, Pesho. They all accept func, which is a delegate, because it works in memory, and because if we hover on this, you see this is IEnumerable. It's I-ordered enumerable, but basically it's an interface deriving from IEnumerable. However, with IQueryable, we have the IQueryable interface, and if we go here to the IntelliSense, we no longer see just the two overloads. We see also an overload which accepts an expression of func, which is something different. It's not a delegate. Let me show you. This is our lambda, and because of even more compiler magic, it could actually be cast both. The C# compiler knows how to cast it both to a delegate, and it can also, however, cast it to an expression of that delegate. And let me just run this. This is a delegate, but this is the expression, and it is built of expression elements which could be then passed on to another implementation. It parses up the lambda, presents the IQueryable implementer with this object tree, and it makes it really easy for them to translate this expression to a language such as SQL. So it's just a cool little trick I wanted to show. So one more thing with expressions. So the first lambda, you can the delegate you can call directly. However, the expression you cannot call directly. You need to compile it first. So you need to call this .compile, which will turn it into a delegate again, and you will be able to call it. So this is basically how it works. And because C# compiler always chooses the most derived interface, in this case IQueryable, it will transparently turn this lambda into an expression. And if we hit run, you'll see that oh, come on. Yeah, okay. Thanks. You'll see it actually generates real SQL behind the scenes in order to do this magic. And you should be very careful with things like as enumerable, because as soon as you call something like this or to list, it changes the interface chain, and it changes also the query. Now, this is a very different query than the one before, because it actually, whenever you switch to a number, everything goes into memory, and it's no longer deferred to the SQL server for remote execution. So this is quite important. And something else, while ORMs are pretty good at translating things like to upper. So yeah, it will translate this. The expression thing is not magical. So if you do something it doesn't know how to do, such as split, you see it will not translate it. So don't trust blindly the technology. I'm racing through these slides because we don't have much time. So let's just recap what we learned here. IQueryable interface expects expressions. Expressions allow for lambdas to be implemented in a different language. And IQueryable implementations allow for query operations to happen remotely. Enumerable interface means you're always working in memory. If you see in your IntelliSense that you're working with enumerable, you're no longer working with the SQL Server, you're working with local memory. Lambdas can be converted both to delegates and to expressions. And various tools, such as ORMs, they take advantage of these features of LINQ and expose IQueryable. And we should be mindful of this because sometimes if we do a second request, it will again go back to the server, and we just need to understand, need to see what's happening. No tool is perfect, and not everything can be translated. So I had one more deep dive demo, but I will not be coding it, but I will go over the ready code because of all the stoppage time. Hopefully you'll be able to see some of that as well. Basically, we are doing what the compiler does, but the hard way, building these expressions programmatically. Okay. So let me just walk you through the code. So we have a speaker class, which has ID, first name, last name. And then we just have a property, which returns a list of speakers. All right. And then we want to query this list according to some criteria. Many times, our query criteria is not known compile times. Sometimes it happens. And if we only know what we want to filter on during runtime, we will have no other choice but to build these LINQ expressions by hand and not rely on the compiler. Because, for example, here we have a static expression which we compile. I will need some extra time. Which we compile, and one we generate dynamically. So how do we generate it dynamically? We base it on a string. We want to filter by property ID and value 1. So how to do this? Well, using the expression object, we start building these expressions, which the compiler does for us. We can build it manually. We declare a parameter, we declare a property accessor, then we do some type safe type conversion here, and then we also declare a constant variable. After that, we build an equals expression, and finally we package it in our Lambda, which, when we are done, produces these expressions. And let me just dump them to see they're identical. We can even compare them here using this tool. So we're basically using code. We can achieve the same thing which the compiler can do for us, and it will filter the list accordingly. It will produce the same results. So what we learned this, it's always easier to let the compiler do it, but sometimes we have no choice, and when we have no choice, we have to do it manually by hand. Performance of this is pretty good. You could alternatively, maybe you saw in the demo code, do this with reflection, but I'm warning you, this is very expensive in terms of performance because it needs to do type safety checks every time reflection is invoked. And but if you only need to do it once, it's way simpler. In order to do it with reflection, you just go get type, get property, get value. Sometimes it's a viable alternative. Again, it's a decision up to the developer. And finally, I was going to show you that it's really easy to extend LINQ with your own operators. They're just extension methods. Unfortunately, I don't have time to show this, but it's extending LINQ is as simple as writing your extension methods. I have some really cool ones. I will post them online after the lecture with all the materials, but we don't have time to go for them. So there's some additional resources, and thank you very much for attending.